Hello everyone, so today I am presenting capillary action, the application of Jurins Law. So in terms of equipment needed, you're going to need some type of measuring device. In this case I'm using a tape measure, small straw or tube. The smaller the radius, the easier it is to measure the capillary height. In this case I'm using glass pipettes, and whatever liquids that you want to use. So for the theory, I'm applying Jurins Law. Jurins Law relates the capillary height to the surface tension, contact angle, and the radius of the tube. And I'm going to be utilizing that to not only back calculate the radius, but also to calculate the contact angle. And so for the first part, when I want to back calculate the radius, I'm going to use water's values. So water against glass has a contact angle of 0. The density of water, gravity, and then all I need is h, and then I can calculate my radius of my tube. And to do that, I'm going to insert the tube into the liquid. And then after inserting it into the liquid, I'm going to measure the height that the liquid transferred up. And we can see after I calculate the experimental radius, we can see that it differs from the manufacturer's radius, and we can see that I get an error of upwards of 10%. In this, I'm having issues with overestimating every single time, and if that's the case, there's probably something that I'm not taking into account, or there's contamination going on that's resulting in different interactions than just the solid-liquid surface. And then I go on to calculate contact angle. The good news is that if I use the manufacturer's value, I get a calculated contact angle of 0 for pure water, which is great. And then for vinegar, we start seeing that a contact angle forms, and then oil having the largest contact angle. And in conclusion, we can see that there's quite a bit of error, and part of that is due to the accuracy of the devices. There's also issues with the experimental setup. One of the issues is that there's going to be an underestimation of the capillary height, the true capillary height, and that's a result of the pipette being submerged into the liquid. And there's that distance between the submerged bottom of the pipette and the surface of the liquid. And that distance technically would need to be taken into account in order to actually look at the capillary height in the way that I'm measuring it. But all in all, some good points. Water's contact angle was calculated to be 0 degrees against glass, which is what we see in other experimental setups. Salt water having ionic interaction is going to show cohesive forces, and I think that's leading to it starting to win out against those adhesive forces that would actually be creating the contact angle to glass. And then oil with the lowest surface tension showed the largest contact angle.